Hello, today we will discuss about test of randomness and median test. These two topics we will discuss today, and this is very important for you. And these both topics are very simple. Here, application of the run theory is in testing the randomness of a given set of observations. Okay, application of the run theory is in testing the randomness of the given set of observations. Let x1 x2 up to xn be the set of observations arranged in the order in which they occur. Okay, let x1 x2 up to xn be the set of observations arranged in the order in which they occur. That means xi is the ith observation in the outcome of an experiment. And then for each of the observations, we see if it is above or below the value of the median of the observations. Note this point. We see if it is above or below the value of the median of the observations, and we write a, capital A, if the observation is above the median of the observation, and b if it is below. Okay, we write a if it is above median value, and b if it is below the median value of the observation. Thus we get a sequence of A's and B's of the type, say A B B A A A B A B B, and let it be denoted by 1. This A B B A A A B A B B may occur in any manner. Okay. Under the null hypothesis H naught, that the set of observation is random, since we are testing test of randomness. So under the null hypothesis H naught, that the set of observation is random, the number of runs, that is u, number of runs in 1. Okay, the number of runs, that is u in 1, is a random variable. Note this point. The number of runs u in 1 is a random variable, and with expectation of u, this is your equal to n plus 2 by 2, and variance of u, this is your equal to n minus 2 upon 4 into n minus 1. These values have been found, and here obtained value are written, and let it be denoted by equation number 2. So here the point, the number of runs u in sequence 1 is a random variable with expectation of u is equal to n plus 2 by 2 and variance of u is equal to n by 4 n minus 2 upon n minus 1 into n minus 2 upon n minus 1. Now if n is large, say if n is greater than 25, then u, that is the number of runs, may be regarded as asymptotically normally distributed. Okay, and now we may use the normal test. This is about the test of randomness, and this is very simple, and prepare this topic. Okay, now we will discuss second topic, that is median test. This is a very important test. Median test is a statistical procedure for testing if two independent ordered samples differ in their central tendencies. Okay, median test is a statistical procedure for testing if two independent ordered samples, note this, ordered sample differ in their central tendencies. Central tendencies means differ in their mean, median, mode. Generally we apply mean and median. Okay, in other words, it gives information if two independent samples are likely to have been drawn from the population with the same median, okay, or not. As we did in the run test, let x1, x2 up to xn1 and y1, y2 up to yn2 be two independent ordered samples taken from the population with f1 dot and f2 dot respectively. The measurements must be at least ordinal. Okay, means two samples have been drawn from two different populations with density function f1 dot and f2 dot. Now it is given that measurement must be at least ordinal, and let z1, z2 up to zn1 plus n2 be the combined ordered sample. Okay, z1, z2 up to zn1 plus n2 be the combined ordered sample, and let m1 be the number of x's and m2 be the number of y's exceeding the median value m. Suppose that median value is m. So number of x's is m1 and number of y's is m2. Of the combined sample. Then under the null hypothesis that the samples come from the same population or come from different population, with the with the same median. That means under H naught, f1 dot is equal to f2 dot, the joint distribution of m1 and m2. Okay, the joint distribution of m1 and m2, and m1 m2 is number of x's and y's. So the joint distribution of m1 and m2 is the hypergeometric distributions with probability function. Okay, means it follows hypergeometric distribution with probability function p m1 m2. This is your equal to n1 c m1 into n2 c m2 upon n1 plus n2 c m1 plus m2, and let it be equation number 1. Okay, this is very simple. As you find probability of two things, in the same way we have found the probability. Now if m1 is less than n1 upon 2, okay, m1 means number of x's is less than n1 by 2, then the critical region corresponding to the size of the type first error alpha. You know type first error of alpha, it is the hypothesis, it is the probability that we reject h naught while it is true, and is called type first error. So if m1 is less than n1 by 2, then the critical region corresponding to the size of the type first error alpha is given by m1 less than m1 dash. Now where m1 dash is computed from the equation, and this is your equal to summation m1 is equal to 1 up to m1 dash, and probability of m1 m2, and this is your equal to alpha. Okay, you have found in above equation 1 p probability of m1 m2. So in second equation you have done simply sum over m1 is equal to 1 to m1 dash, and it is equal to your alpha. Now the distribution of m1, that is number of x's under h naught, is also hypergeometric, means it follows also hypergeometric distribution with expectation of m1 is equal to n1 upon 2 if capital N is equal to small n1 plus n2 is even, and expectation of m1 is equal to n1 by 2 into capital N minus 1 upon capital N. Okay, if n capital N is odd, and variance of m1, this is equal to n1 small n1 n2 upon 4 capital N1 minus 1 if capital N is even, and variance of m1 is equal to n1 small n1 small n2 into capital N plus 1 upon 4n square if capital N is odd. So we have expectation of m1, that is number of x's, equal to n1 by 2 if n capital N is even, and this is your equal to n1 by 2 into capital N1 capital N minus 1 upon capital N if n is odd, and its variance is given by n1 n2 upon 4 into capital N minus 1 if n is even, and this is your equal to n1 n2 into in bracket capital N plus 1 upon 4 capital N square if capital N is odd. So let it be equation number your 3. Okay, this distribution is most of times inconvenient to use. Okay, this distribution is most of times inconvenient to use. However, for large samples we may regard M1 to be asymptotically normal. Okay, and we use normal test. That means Z is equal to M1 minus expectation of M1 upon under root variance of M1, and these follows normal distribution with mean 0, variance 1 asymptotically. Okay, and let it be equation number 4. So this is about your median test. Now there are some important points, so note this. Note number 1: if the observations M1 and M2 can be classified into the following 2 cross 2 contingency table, and this contingency table is shown in table. Here we have 3 columns for sample 1, sample 2, and third column is for totals. Here number of observation greater than m, that is median value. In sample 1 it is m1, in sample 2 it is m2, and total is m1 plus m2. Okay, and number of observation less than m, capital M, that is median. So in sample 1 it is n1 minus m1, since number of total excess is n1, and m1 is number of excess, and in sample 2 we will have n2 minus m2, and total will be n1 plus n2 minus m1 minus m2, and total is sample 1, total sample observation is n1, and in sample 2 total number of sample observation is n2, and total is n1 plus n2 equal to capital N. Okay, this is very simple. This is 2 cross 2 contingency table. Now if the frequencies are small, then you can compute the exact probabilities from the equation number 1 rather than approximate them. However, if the frequencies are large, then we may use chi-square test with 1 degree of freedom for a 2 cross 2 contingency table for testing H naught. Okay, point number 2, median test is sometimes sensitive to the differences in location between f1x and f2y, but not to differences in their shapes. Okay, median test is sometimes sensitive to the differences in the location between f1x and f2y, but not to the differences in their shapes. It means if f1x and f2y have the same median, then we would expect h naught f1 dot is equal to f2 dot to be accepted, even though their shapes are quite different. Okay, and number 3 points is, that is, generally the median test makes the correct decision. Okay, the median test makes the correct decision with a little more assurance, with a little more assurance than does the sign test, but not as the t-test. Okay, these are the 3 points and very important point. So this is all about of median test. So today we have discussed test of randomness and median test. So keep yourself happy. Thank you.